Cool. So I'll be presenting on privacy Legos here. I am the simple kid. I work on Cashu dev kit, Spiral grantee, and I'll be presenting on how Cashu fits into the Bitcoin payments ecosystem, and how it kind of can extend Lightning and Bitcoin payments on chain. Yeah, so like I said, I work on the CDK, which is the REST implementation of Cashu, cashudevkit.org. You can learn a little bit more about CDK specifically. Yeah, so your Bitcoin payment stack. So obviously we have Bitcoin, the base chain, which has, our fundamental, everything eventually settles down to layer 1 Bitcoin. And then on top of that, we have Lightning for instant fast payments. And then this presentation is how does Cashu fit into that? Why do we need Cashu? What does Cashu allow us to do that Bitcoin base chain and Lightning don't allow us to do? And what are the benefits of those and drawbacks? So Bitcoin layer 1 is of course trustless and secure, right? Like it's decentralized, hard cap of 21 million, all these things that are good for a monetary system. But as to make those things possible, it has slow confirmation times, around a 10-minute block time, high fees for small amounts, and there's a public ledger. So obviously a privacy drawback, despite being good for decentralization. So to solve some of those problems, 10 minutes is obviously a long time to wait when you're paying your coffee or like paying a high fee. So we have Lightning. This allows for the instant settlement and lower fees, but the drawback of Lightning requires an online presence. You have to have your Lightning node always online. Both the sender and the receiver have to be online, with some slight exceptions for things like hold invoices, but for the most part, you both have to be online. You have channel management complexity. So to run a node, you have to manage inbound and outbound liquidity, which is quite complicated for someone who just wants to be able to pay. And interactivity, I kind of already talked about this, with requiring the online payments. So this is where Cashu comes into play. We have instant, private, and potentially offline payments that can be denominated in Bitcoin. So what is Cashu? Cashu is a bearer token. It's just a text string. I'll show one in a little bit. So it's like physical cash, but digital. You can pass it directly, this text string, and then the person is able to claim this immediately. It's not this other thing. It's an actual bearer token. It uses blind signatures. This is what gives it its privacy. The mint is able to issue these. The way this works is the wallet submits a blind signature or a blinded message to the mint. The mint is able to sign this, and then later the person's able to redeem this without the mint knowing exactly that they signed this specific message when. So this breaks some of the privacy heuristics. Lightning enabled. So Cashu is fully interoperable with Lightning. You have your Cashu wallet with your tokens, and someone shows you a Vault 11 invoice, and actually now with CDK Vault 12, and you can pay this. Like, they don't know you're using a Cashu wallet. You don't have to go, oh, do you accept Cashu? No, it uses Lightning, and you can also receive Lightning. So if someone wants to pay you, you show them a Vault 11, a Vault 12, or an invoice, or a Vault 12 offer, and they can pay that with their own node that they're running on their Raspberry Pi. They don't have to go get a Cashu wallet. It works completely with Lightning. It's possible that it could work with on-chain as well. We just don't support that yet, but maybe in the future we'll do that. Also, there are potential offline capabilities. You can do things. One, if you trust the person you're paying a little bit, you can give them a token offline, and just you don't revoke it on them, and they can claim it at a later point. If you don't trust necessarily the person, you can do things like pay to pub key locked. So they give you a token or a public key to lock to, and you lock this token. This would require the sender to be online. You can also do things where the reverse, where only the receiver is online. In that case, you don't need pay to pub key locked. You just give them the token, and they redeem it. So you can be offline, and the receiver can be online. This would work well for like things like POSs. You often see like One end is offline. Programmable conditions, so I mentioned pay to pub key locked. I'll show a little bit more of this later. Right now in Cashu, we have pay to public key, so you can lock to things like Nostr pub keys or whatever, and we have HTLCs. Cool. That's showing the full thing. Yeah. Yeah. So like I said, Cashu is built on top of the Lightning network right now. So you have a Cashu mint that sits on top of a Lightning node. So the way the flow kind of works is the wallet would request a quote from the mint. The mint asks its Lightning node for a Vault 11 invoice. The mint then passes that to the user. The user pays this, and then they come back and mint. So this enables the user to be able to pay and receive via Lightning without having to run their own node. They can use the mints. And because it's eCash, they get some privacy benefits. Yes. So where do we want to add Cashu into this like privacy Lego payment stack that we have? When we really want privacy, Cashu is great for privacy. Instant, because you can do that offline transfer of just giving someone a token. It can be incredibly fast and instant. Offline, you don't have maybe internet micropayments because you're just passing this text string. There's like potentially no fees until you melt in and out. If you're staying within Cashu and you're just swapping, most mints now have no fees. We do have fees in the spec, but no one's using them yet. So you can have essentially free transactions. And then if you want to be able to program with HTLC, the pay to public key, and then simplicity, right? Someone just wants to use Bitcoin, doesn't want to deal with setting up a node. Cashu is great for that. So use case one, micropayments and paywalls. So we have this. So if you see here, this curl request here, this is, I'll do a demo of this, I think maybe the next slide. Athena is this search thing I built. It's built on top of the Kagi API, but you don't have to have an account for it. So this is where Cashu really shines. All kind of APIs, whether that be AI or search APIs, because payments in today's world, a credit card, you can't do, a 5-cent transaction, right? There's kind of like a minimum, like $2, probably $5 is like, because of this chargeback risks, there's no way that a credit card can handle just like a couple cents. So to solve this, we have in this spec, forget the number at the moment, but essentially what it is this 402 required. So this is in the HTTP spec, 402 payment required. So what happened here is I curled this endpoint that requires payment without providing it a token. So it gives me an HTTP payment for required with this Cashu header. What this is a payment request, and it tells the person what they need to provide. So if you decode this, it will say like, you have to pay one. In the case of this actually uses custom units that are like search tokens. So it says you have to pay one search token from mint.athena.com. And you can also add in spending conditions. So you can say, and it has to be locked to this public key. And then you can retry the request with the correct payment. So you'll see here, so then you curl it again with an Cashu token. Obviously you need the full one. But now you get your results, right? Perfect. So it enables this paywall purpose without an account. And this also is much better privacy since you can do, your requests aren't linked, right? If you have an account, you do request 1 from your account, you do request 2 from your account. Those are obviously the same person. With this, since you'll use 2 different tokens, those 2 requests are not linked. Obviously, you'll have like network potential linkings, but if you use Tor or VPNs, you can break those. I just realized that's not a valid Cashu token. This should be Cashu A, blah, 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 but that's fine. So on the server side, like how does someone receive this? And I'll show how Athena works now in a second, but a cool thing about this is there's actually two ways to do it that we've thought of so far. Maybe there's more. One is this way, where you can actually use a Bloom filter, and this way the service provider, like the Athena in this case, they can just be a Cashu wallet. They don't have to run their own mint. They're a Cashu wallet, and they use pay-to-public key lock tokens. So they'll publish the public key that you need to lock through in that payment request that I showed earlier. And then there's epochs. So you send, when you're in epoch 0, the public key is whatever, and everyone locks to that and sends it, and then the service provider just all they have to maintain is this Bloom filter. They don't even necessarily need a database. So every time they get a request, they verify that it's a valid DLEQ. So what that enables is they know that it's signed by the mint and a valid signature from the mint without having to check to the mint. So what this enables is it skips a round trip to the mint, right? You don't have to do an extra round trip because obviously that would introduce latency. So the first step here is at the top you see the spending conditions that it's expecting, so like the lock time, the public key that it's expecting, and then we verify that. So we verify that it's a valid CDK, valid DLEQ. We verify that it's a valid public key, so we know that they can't double spend it. We're the only ones that the mint will allow to spend it. And then we add it to our Bloom filter. This protects us from being double spent. So we do need to do our own double spend protection. So during this epoch, we add it to our Bloom filter. And then at the end of our epoch, we rotate our public key. We rotate our public key. We claim all the tokens we acquired during that epoch from the mint. So now we do one round trip with the mint claiming all these tokens. And then we publish that public key, or the private key for that public key. And that way, anyone that's locked a token expecting to spend, but didn't actually end up spending, is able to get their eCash back. The other way this works, and this currently works with Athena now, is you can do a custom mint. So right now, Athena has like a custom mint backend, and the mint and the service provider are the same. This has some benefits in that it allows you to do custom tokens. So like Athena uses search tokens. So like every request is one search token. And this is nice because it makes the wallet very simple. Like there's no coin selection. You just like pop the list for the next token, send it. But it's a little bit more complicated because you have to run a mint. So I'll just do a search here, like Cashu or something, and we'll see the request, hopefully. So now you get your results. Like this is like the Kagi API. Like I'm not running my own search index or anything. You guys probably can't see that. And then I can show you the actual here. Yeah, so you see here, you can see that right? You see here, it made the request. Our search was Cashu, and we included our Cashu B token. This is a valid Cashu token with one search token in it. And so this is our payment for the request. Yeah, so that's pretty simple there with Athena, and obviously, top up with Lightning. See if that works. Yeah, you just pay your Lightning, and this mints. This is in the case that the mint and the service provider are the same people. So I think I had the next slide is another demo. So another thing I built here is, I don't know if you're familiar with Goose. It's like a agentic AI tool from Block. And the way Goose kind of currently works right now is you give it, I'll show you. You configure your provider, whether that be Anthropic or whatever your provider of choice is, but you give them your API key, and this is equivalent to your account. So every session, every query is all related to that one account. So they can link all your accounts together, or all your queries together. And obviously this is negative for privacy. If you're doing, it's one thing you're querying about your your coding project and then you want to do some querying on your like your taxes or whatever, maybe you don't want those two things linked. But in this way, there's no way to break this, since the current model requires you to like prepay with a credit card, get an API key, and then do this. But there's this project called Routester, which is like Nostra based. Um, you can publish what models you can support over Nostra, and then you can include a Cashu token in the request, similar to what you just saw with Athena. So I don't need to do the configure because I should have it already configured. So I'll start or actually I will do this first. So here I added just a few like CLI commands to Goose. So like one is like this wallet command, so you can see the balance. So like you have currently, a little over 1,000 sats in worth of query, and then you top up just via Cashu token. I won't do it since I already have a balance, but you top up, you just give it a Cashu token, and you've now incremented your balance by whatever. And then in the query, like you won't be able to see much, but like what is Cashu? There's like a little bit of logging here that you should be able to see. When it does this query, it includes the Cashu token in their request. So obviously with AI, it's a little bit, you don't get the exact privacy benefits you do with Athena, because like this new session, I haven't linked to my other sessions, but obviously, if I do another request, it has to send the context back. So when you're in the one session, you will continue that the AI, all those queries will be linked, but it's incredibly easy. Kill the session, new token, and you now don't link your two sessions together. So yeah, you see like your normal Goose output, but you've paid in Cashu, and if we exit, you should see our balance. I forget exactly what it was, and this is a pretty cheap model, so I think it only cost us 1 sat. But yeah, before is 1102, I think. So yeah, that's Goose. Works pretty nice. Routester is still, it's a very cool project. Pretty early days, so we'll see where that goes. So yeah, no API required for accounts, and that's kind of like the main thing of like this paywall stuff is like you don't need accounts, and like Cashu in general, like you don't need accounts. You can do these payments without accounts because the token is the payment. So you can't do this with Lightning because there's like L4 too, but that introduces an extra round trip. Whereas Cashu, you make the request, you include the Cashu token in the header, and the server side verifies that via the method we talked about with the Bloom filter, or with the where they're their own mint, and it's all done right there. There's no extra like round trips or anything like that. Another thing with Cashu is like you can do like tipping and donations. I think Ege is actually doing a talk on this later if you're interested, with more like code demos. But right now, Lightning with Vault 11, you can't really post a static identifier anywhere, right? Like you can do this with Bitcoin, but then everyone knows exactly how much gets donated to you. Vault 11, you would have to change this, so like there's ln URL, but that's interactive. You then have to introduce an extra web server. You query the web server to get your Vault 11. Cashu, we have these things called payments request. This is the encoded. The bottom here is the encoded. So you could post this text string on your website, and that static can be reused as many times as you want. And you encode what you're willing to accept. Like probably for a donation use case, you don't want to set an amount. You'll accept whatever eCash someone sends you. But you could set an amount if it's for like a specific thing. But the kind of important part here is like the end profile and the NIP17 DMs and the Nostra. So this here is the transport. So Cashu, we also have like posts, so you could accept an endpoint with post. Cashu tokens over the post. But here's Nostra. So like you just post this, and then a Cashu wallet can read this, and it just fires a Cashu token over Nostra, and you just then at a later point, you don't have to do it immediately, query that Nostra relay and get all your tokens. So it enables this. The receiver does not have to be online to accept these payments. Is kind of the real benefit here. Yeah. So as you see, payment arrives when they reconnect. And then a little bit more about the offline transaction use case. Um, so you often, I was actually in basement last night. Maybe I shouldn't admit that, but they're kind of POS. They didn't have great internet connection or whatever. So like you would pay it, and then they got no thing on their end. So they were like, did it go through? And I was like, yeah, it went through. Like I paid, but they couldn't actually see this. So in the case of Cashu, I just give them the Cashu token, and they could verify that on their device using DLEQ proofs, and if it's pay to pub key locked, um, and they don't need an internet connection. So in that case, I would have the internet connection. I scan a payment request that includes the public key that they want me to lock to, public key that they want me to lock to, and and then I send that token to them. And then later, when they do have Wi-Fi, they can reclaim all those tokens. And there's no risk of double spent because of that pay to pub key locked smart contract. The other use case is the reverse. If I'm offline as the sender, right? Like, and this is how tap to pay currently works with credit cards. You have the token on your device, and the POS reads it. If the sender is offline, then I transmit the token to them. Like then this can be an unlocked token, maybe via bit chat, right, or Bluetooth, and I send them that token, and then they immediately swap it from the mint. So that's what their double spend protection is there. They swap it from the mint. They don't need pay to pub key locked tokens. So it enables this offline use case depending on if the sender or the receiver is offline. Both can be supported in Cashu. You can have both offline, but you kind of need to either semi-trust the person that they're not going to double spend you, or you need to know ahead of time that you're going to pay them and pre-lock the tokens, and then when you actually do the transfer. So like this could maybe work in like maybe a festival situation, right? Like you go in and you pre-lock however many tokens for the weekend because you know you're not going to have internet, and you go around the token and you can spend all these. They can be received later, and then at the end of the token, that public, maybe that private key, similar to that Bloom filter use case I showed, is published, and anything you didn't spend, you can reclaim. So yeah, offline transactions, and then I kind of talked about this already, like the programmable things. So like I talked about pay to public key tokens already, and kind of what that enables. I'll talk a little bit about HTLCs. So HTLCs, one use case we've done, obviously, where Cashu kind of enables Lightning already. So you don't necessarily need to do this, but like one thing you can do is Lightning gateways. So if maybe you have a mint that has like a bad Lightning connection on a day, right? But someone else is running a Lightning gateway and they're willing to pay these payments, and then they'll get it from the mint at a later point, right? You can send them the token HTLC lock to the HTLC of the Lightning invoice. They pay it for you, and then they're able to claim the eCash. But if they don't make that Lightning payment, then they can't receive it. You can use other things with HTLCs. They haven't been used too much in Cashu yet, but maybe we'll see some interesting stuff going forward. Yeah. Yep. No. So the way the P2P lock token is, if I'm the sender, I do a swap with the mint. So like I get the receiver's public key. I then put that in our nut 10 spending conditions, and then I give that to the mint, blinded, but then they sign it, and then you now have the secret that includes the public key. And then when the receiver wants to spend it, they have to sign this thing before, right? Yeah. You get the mint to issue to specific, issue a thing. But the nice thing is, because it's blinded, they don't know that at the time they're doing it. So you still have these like privacy benefits. Yes. The sender has to be online to lock it, and then once it's locked, they don't need to be online. But yeah, Yeah, you have to pre-lock. Yeah, that's why it's like not the like the what. Yeah, it's a trade-off. Like one kind of needs to be online. Is like the best way this works. Um, yeah, so Cashew kind of has some nice privacy benefits. Like there's no blockchain, right, that has everything you're sending. So you don't have this like transaction history. Lightning as well, like in Vault 11, at least Vault 12 kind of fixes this, but you have to reveal the public key of your mint, right? So you can see kind of what or sorry, what node they're using. So you don't have any of those revealing things in Cashew. Obviously, the big trade-off to this is it is custodial. Like the mint um, is the one that has the actual Bitcoin, and you have these eCash, which are IOUs. And then in Cashew 2, it's single mint. So if that mint is not available for whatever reason, then you're stuck until the mint comes back on. So the main trade-off to Cashew is it's custodial. But for like small amounts and these privacy benefits, it can be a good trade-off. And yeah, small amounts. You can use multiple mints. So like we have multiple mint MPP payments. So you can actually pay one Lightning invoice for multiple mints at the same time, which is quite cool. Um, and then yeah, so future like multi-nut payments. This is that multi payments, and this allows you to like spread your risk out across multiple mints. And then like when you're paying, you just pay from all the mints at the same time for bigger amounts. Time locks, interoperability. Uh, it's quite easy. So like ecosystem growth, I think like a lot of you've probably seen like it's pretty easy to put a Cashew wallet in things. So we've seen this a little bit with like Nostra. Um, we did one with BitChat. We put a Cashew wallet in there. So it's nice that it's like it's quite a simple protocol, and we're now doing things like with CDK. We're doing bindings, so like it handles all the Cashew logic for you, and you just get the like fairly simple APIs. And so you know if you have an app right now that like you don't have payments in because it's difficult, Cashew is quite easy to add to these payments. So yeah, so SDKs, CDK um, enables you to do this. Merchant tools. So we've actually seen BTC Pay have a plugin now, so that you can just do that. You just give the BTC Pay server a token, and they can handle that whichever way they want. Add things to Nostra. Payment APIs. Yeah, so Cashew Dev Kit. I'm obviously a developer working on Cashew Dev Kit, which is a Rust implementation of Cashew. Um, I like to think it's easy to use, so if you want to build something in Rust, Cashew's a good, CDK is a good try. We also have libraries in TypeScript, Python, Go. I think we might have a Java one. I don't know. Yeah, further resources. CashewDevKit.org is for CDK stuff. Cashew.space and docs.cashew.space are like wider Cashew stuff. If you're interested to learn more, and yeah, that's it for me. Thanks. Have 1 minute and 30 seconds for questions. Yeah, yeah. So we're doing Unify. So we will have Swift, Python, and Kotlin. Currently, right now, we have had them working, but it's quite a manual process. We just like kind of hacked it together, get a bunch of build scripts to get it working. But hopefully, in like a week or two, like actually a week or two, not the 2 weeks, we should have nice, simple ones that can actually just be pulled in, and ideally to the end user, they'll just look like native packages. They won't even like we can publish them to like Maven or Swift does it just through GitHub. But then a Swift developer can pull that in, and it just looks like a Swift package. They don't even necessarily know that it's Rust under the hood. Yeah. 30 seconds. Anyone else? All good? Perfect. Thank you.